I'm going to talk about some quick wins for more secure software. This is probably like the least technical talk I've ever really done. I've been at my company for about a year, Sabre, and I've kind of been introduced to the enterprise IT security world and how they kind of clash with development. So I used to be a developer, but now that I'm in IT security, I actually see kind of the friction that happens. So I'm going to talk about maybe some easy things, some quick wins you can do. First of all, I do work at Sabre, not associated with the Dunder Mifflin Paper Company. Don't know if any of you enjoyed The Office, but I do have a short video clip I would like to play. Another cloudy gray afternoon. Jumped in the cab, we walked for the first time. Look to the right, and you see the Electric City sign. This is gonna be a good day. For Dunder Mifflin and Sabre. Not Sabre.
Sabre.
It's Sabre. Dunder Mifflin and Sabre. So yeah.
Dunder Mifflin is a part of Sabre.
Say yeah. Dunder Mifflin is a part of Sabre.
It's a part of Sabre.
You sure it's Sabre?
Start over here with a little bit more about me. So, like I said, I've been at Sabre about a year. Currently, I do everything application security. I'm really the only AppSec guy at Sabre. We have about 2,500 or so developers, a lot of them at our headquarters in South Lake, Texas, many in Poland, some in India, other places around the world. So previously, I was a solutions architect at Veracode and also a consultant on the AppSec team at Fishnet. But like I kind of mentioned, originally I started life as a developer. The first 12 years of my career, I didn't know anything about security. Then I got into AppSec around 2004, and I've been doing that ever since. I do really participate in OWASP quite a bit. I worked with Jim Manico on the Forgot Password cheat sheet. Have a couple certifications, and I enjoy writing on a blog from time to time at appsecnotes.blogspot.com. So as a IT security person at an enterprise, in terms of application security, your mission, your job is to try to reduce the odds of an application hack. Essentially, you want to avoid bad things like compromised data, loss of data integrity, having malware on your systems, denial of service attacks where you might lose revenue, fraud committed against your systems, any kind of bad press which would cause damage to your reputation, cost, like credit monitoring costs, it's a PCI breach of some sort, fines, and maybe even loss of your job, like we saw at Target. CEO and CIO both lost their job from the breach there. So with that in mind, what you would want to do in a perfect world is get some blessing and budget from executive management. You would want to initiate a formal application security program, have a team, a software security group of some sort to manage all the activities that need to happen for a really solid AppSec program. You want to establish processes that are vetted and accepted around the organization, select the best tools, hire great talent, track your progress and your improvement over time with a maturity model, and you can demonstrate the return on investment to the executives. And just in generally, you vex hackers. All right, so that's the goal. It's not always the case where that's going to actually work. For one thing, in terms of the maturity level, it doesn't happen overnight. It's a process. And I just took a few sample charts from various maturity models and other marketing information about how you start off with kind of an ad hoc approach, and ultimately, on the most mature level, you've got everything working smoothly. You have an optimized program, and everything's working nicely. However, you don't always have the advantages that you need in terms of budget, resources, time to do such a great job. So I want to talk about some of the complications that I've seen, and I know other organizations around the world are seeing as well. First of all, you may not have a mandate from executives. A lot of times, well, I would say most always, the grassroots approach to application security, where maybe the IT security team or some developers decide they're going to get a program going and they're going to have a grassroots effort to get it going. Not necessarily going to work because the development side is, they're not being graded on the security of their applications. They're going to grade it on the performance. Is it done on time? Does it work? If there's no mandate from their management to include security, why would they listen to these people or this IT security guys saying that they want to improve the security of the software? There's a lot of applications in your organization, many websites, web services. You have limited time, limited budget. Staff and expertise is always an issue. At Sabre, they about a year ago decided they didn't have the application security experience on the security team. That's kind of why I ended up there. However, just to be honest, I'm feeling a little bit overwhelmed right now because we're a huge software technology company. We write a lot of code, and I feel like I'm looking for ways to make a difference right now. And I do in individual teams that I work with, but in a company-wide, I feel like I need more staff and more expertise in application security. In terms of mixing with the development teams, like I said, without the development side having a mandate to include security, a lot of times you'll get resistance to suggestions how they might improve their processes or improve their security of their code, or heaven forbid you find vulnerabilities in the code and you tell them about that. So here's some general thoughts that I've had on the topic. So first of all, the goal is to defend your applications and your enterprise network. So you first need to understand what you have. That's kind of an inventory that needs to be taken. A focus on your external presence is probably most critical when you have limited time and resources and budget. You can certainly ignore static sites, marketing sites that are just static HTML. Keep in mind that you don't, on the IT security side, you don't necessarily fix the code or write the code, but it's important to think like an attacker. For commercial software, you have a couple of options. First of all, you can ask directly on the vendor how they secure their code when they're developing their products. What do they do specifically? And also review the hosting infrastructure of these vendors' developed products and the server configurations. But in terms of the code itself in a commercial product, you're really kind of at the mercy of the vendor. There are some interesting sort of securing the software supply chain initiatives going on out there. I know Veracode has a vendor application security program as part of their offering, since they can basically scan the vendor's code, a static analysis approach, and provide high-level results to an enterprise, so you can get some idea of how secure or insecure a vendor's application is. But if it's an internally developed app, you have a lot more options. One of the things that I've initiated at Sabre is a questionnaire to gauge the relative risk of an application. I'll ask things in the questionnaire. What's the purpose of the application? How's authentication done? How many user roles? Are there multiple roles, for instance, an admin level, or standard user, or whatever? How is data encryption done, or is it done? What kind of logging is done? And is it external, internal facing? So one thing I have found useful, and back when I was doing application pen testing for Fishnet, is I kind of grew up using Burp in the AppSec side. And so Burp Professional is an indispensable tool. The Pro version is only $299 per year per person. And with that, you get a web app scanner. We use other tools for web app scanning at Sabre. But this in particular is a tool that I use. We don't ask the development teams, for example, to use it, but I use it to scan interesting URLs, at least for the web app scanner part. You know, what's an interesting URL? It's a URL with a query string or has a post request where there's a lot of parameters in the body. So that supplements our main web app scanning that we do for PCI. But Burp also includes an intruder, which is a nice data fuzzer. Repeater for testing specifically manual testing of particular issues. Spider, decoder, and there's extensions with Burp that you can download from the website. And it integrates with other tools, including Qualys WAS, WebInspect, ThreadFix. How many of you use Burp? Okay, almost everyone knows. I'm speaking to the choir here. Okay, so let's get into some quick wins. Some things I think that are useful, don't cost a lot of time, money, and resources. So first of all, get your inventory figured out. What applications do you own? This has been surprisingly difficult for me over the last year. There wasn't anywhere where that information was kept. I've had bits and pieces and drawn it in. I have a nice spreadsheet that I'm keeping up to date. So it's just important because you need to understand your external facing web presence, essentially, because you can't secure what you don't know about, which I think you've heard today and yesterday. So also, one of the things that is really easy to do, it should be easy to do, but it can provide a lot of value, is just decommission old obsolete apps. I know that there's times when I've found applications that are still running. There's newer versions that have replaced the older version. The older version is still running because there might be one or two customers using it, and the business, well, we can't turn it off. We still have a couple customers using it. That's a scenario like, well, okay, let's talk to the business and the team about the advantages of reducing your attack surface. Because then you don't even need to test that app. You can just make it go away. Very useful. Consolidating duplicate apps, turning off functionality that's not needed. There's a lot of times I've talked to teams and I've asked them, okay, what does this part of area do? Oh, we don't use that anymore, but it's still there and it's still running. So, you know, remove that from the build, and so you don't have that code even visible anymore. And superfluous content. So that's not necessarily functionality, but it's documentation, static files that have made their way onto a web server, and it's externally facing, and it's potentially information disclosure type of an issue. So how do you find your attack surface? Well, of course, internal resources and the teams to know what applications there are. But there's other ways that I've found useful working from the security side. And Google hacking, or dorking as it's called, getting file listings from servers. OWASP has a product or a tool called Dirbuster that I like, and also Veracode has a discovery service. But let's talk about Google hacking. I'm sure everyone knows this, but the advanced search operators can really help you. I happened to just, not long after Target got breached, well, this was probably like this past summer, I decided, okay, Target got breached, they've probably really locked things down at this point. So I just went to Google. I wanted to see, okay, what kind of web content is out there facing the internet. So I did site:target.com. And I got a list. One of the ones that looked interesting to me was this coupons, the third one down. So I decided to kind of refine my Google hacking search, and I searched for the word login in only the coupons.target.com host. And very quickly, I found this was interesting to me. This is where I stopped, but I found a Cold Fusion site. Cold Fusion site that has authentication, and it's some sort of administrator-related functionality, because I found all those words are there. I don't know if that's vulnerable or not, but that's the kind of thing that you can do to find content at your organization. By the way, does everyone know that there are actually Cold Fusion conferences still happening? No. They actually are. In fact, I was in Las Vegas last week, and I happened to be right next to one. And I have a screenshot here. I took a screenshot of the agenda, and one of the items at 1:30 p.m. was Don't throw that out. Bringing legacy, it's short of bringing legacy Cold Fusion code into this century. So there are still active developers out there in Cold Fusion. That was a surprise to me. It's had its problem in the past. All right, so Dirbuster. Has anyone ever used Dirbuster? Okay, so it's really easy to use. I mean, there's nothing like complex about it. It basically has a huge file list of common directory and file names. You fire it up. It's a Java application, Java desktop application. You fire it up. You point it at the URL, the target site. And it's actually a file and directory brute forcer. And so you can specify here if you want to brute force files as well as directories, you can specify a file extension. You can tell it if you want it to be recursive or not. So if it finds a directory, it'll start searching subdirectories under there. So basically, you're just looking for content that maybe have interesting or possibly vulnerable functionality or anything that maybe not supposed to be there. It's amazingly adept at finding content that maybe you couldn't find manually by guessing. A lot of it has to do with the file lists that come with Dirbuster. I've kind of refined it over myself. I've added to it. I've taken some stuff away. Like the file list actually have a lot of like kind of porn-related words that I don't even want to look for, so I remove all those. I add a bunch of others that I know that are often out there. And now I've done that over the years, so I have a pretty good list right now that actually I should put on my blog or something sometime. Other people might find it useful. But you just fire off Dirbuster, and it goes, and it gives you a nice tree directory listing of everything it finds. So that was quick win number one. Basically, it was reduce your attack surface. Quick win number two, shore up your SSL configuration. Now, I put Heartbleed on here only because there's actually a brand new version of OpenSSL came out about a week ago, 1.0.1J. I'm not exactly sure what security fixes that it addresses. I know that it mentions there are some in this version. So I thought it would be good to just make mention of that. Obviously, anything before 1.01F is bad. Also, testing your SSL configuration is really easy to do. There's several options here. A long time ago, I used THC SSL check, SSL digger, SSL scan. Those are really out of date now and have not been updated. So I would not use those if you are using them now. The two that I've been happy with and are being kept up to date are OSAFT from OWASP. And then the Qualys has a free cloud-based SSL tester that you can use. It's also always continually kept up to date. It's pretty good, and it's free. Both of those are free there. And then, of course, testing cookies are marked secure. That's important. So OSAFT, it's a free Perl command line tool. You can grab it at this URL. And you fire it up, and it has all kinds of interesting information about your SSL configuration. It's almost overwhelming, actually, but you can really geek out with any information that it provides. The Qualys SSL test is at that URL there. It's free, quick and easy, nice report, really nice report you can print out and send to someone to explain the problem. It'll check for things like SSL v2 and Heartbleed and Poodle and all these other things. Interesting thing is, if you do put in your host here, the site you want to test, I always like to check the checkbox that says "Do not show the results on the boards." Otherwise, you get everyone goes to this page can see the results of your scan. Yeah, I'm not sure why that's not checked by default. Maybe Qualys wants to just make it available to everyone. It even says, these are the most recent worst scans. So these are all Fs. So it's probably somebody screen scraping this like every hour and collecting all that. A real simple one is, sensitive cookies need to be marked secure if the site is running under SSL, which it should be, or TLS now. We really shouldn't be using any SSL. But the Firefox developer extension is a quick way to check if it's marked secure or not, and HTTP only. It shows you both of those when you do view cookies. All right, so that was number 2, the SSL, shoring up your SSL configuration. Number 3 is quash the number 1 baddie, which is SQL injection. And I went to Jim Manico's talk yesterday, and he explained it very well. Is like, you should not have this in your environment anymore. It's first of all, it's very easy to fix. If developers do this one thing, which is use parameterized queries, then all the problems with SQL injection go away. If they don't do that, then you may have SQL injection. So it's very black and white. It's not difficult to fix. But if your organization has a lot of code that's been written over the years, it's important to know if you might have SQL injection in that code. And so you need to test for it. How do you test for it on kind of a budget, if you're budget conscious and you can't pay pen testers and you can't buy the top of the line tools or whatever? Well, there's a lot of different ways. You can grab this Firefox extension called SQL Inject Me that will test an individual page or a form. You can download this NetSparker community. Has anyone used NetSparker? It's a scanning tool. You may have not heard about it. It's similar to WebInspect, AppScan, but there's a community edition, and it actually does full checks for Crosssite Scripting and SQL injection. So that's a good way to do it. I've run it recently and found it to be pretty accurate. There's obviously like a pro version that has a lot more options. Community edition won't let you generate reports. Like you can't generate a report like a PDF report. So it's been handicapped on purpose, but it'll help you find SQL injection. Obviously, the unauthenticated surface area is your number 1 priority. So if you're limited on time, don't worry about getting a login for the application and testing the interior. Just make sure the login page, the contact us page, the forgot password functionality, all that stuff that's from the unauthenticated surface area is tested real well. And by the way, all these tools, I know NetSparker, for example, tests for blind SQL injection with some timing attacks, so it doesn't necessarily have just look at SQL errors that come back in the response to know if there's SQL injection. They're a little bit more advanced than that. All right, so like I said, developers do have the power here. The SQL injection cheat sheet on OWASP is very good. This is for if you're talking to a development team and they're not familiar with it, they want some guidance on how to fix it. This is some information you can give them. Nice video tutorial. I think Jerry Hoff did that, and it's only 10 minutes long. Okay, number 4. Quash unauthenticated XSS. So again, I'm looking here at Crosssite Scripting, making sure it's fixed from an unauthenticated perspective. Those are really probably an order of magnitude worse because they're perfect for phishing. And so getting that fixed from the unauthenticated point of view is important. OWASP Zap. Now, I haven't used Zap a lot, but I hear really good things about it. So have you guys used it? Yeah. So I know it's had a lot of advancements lately. I think it was a fork from Peros, like back in the day, which I used a long time ago. But it has a free scanner for XSS. And again, NetSparker, like I mentioned, also can test for XSS. And the pro version of Burp, its scanner is very good at testing for XSS. So fixing is not quite as simple as SQL injection, unfortunately. Encoding is really what you need, and this is where Jim Manico is really good at explaining the types of encoding that you need to do. And blacklisting is a big no-no. I know one of our teams were fixing a lot of the event handlers, like on mouse over and on click and all these things. There were some issues with Crosssite Scripting there. And so, unfortunately, a blacklist was being used. And there's probably 3 dozen different mouse events that can fire in various browsers. And it was like trying to chase your tail, trying to get every single instance of the mouse events to return an error on if you see it in the request. So obviously encoding that data is much better approach. Also, content security policy. It's an HTTP response header that every web application can set and tells the browsers that only JavaScript code from this particular site is going to be allowed to run. Kinzia, next works for Sigil, has actually a whole talk on content security policy in about an hour, or actually at 1, I think. And there's a video tutorial on Crosssite Scripting in there as well. So IE and Chrome, as you probably know, have some built-in protection against Crosssite Scripting. Because one of the things that's important is to demonstrate to the developers or whoever is going to be fixing the Crosssite Scripting what you can do. Demonstrate to them how it's a problem. So usually it's important to use Firefox with that unless they turn off the filters, the XSS. I think IE it's called XSS filter. Chrome it's called XSS auditor. Firefox doesn't really have anything built in. A lot of people use NoScript to accomplish the same thing. But typically you want to demonstrate cross-site scripting as possible and make it impactful to them so they see, look, this is bad, someone could do this. Now historically that's been done with the alert pop-up box, right? Not very exciting. So I recommend some other options. One of my favorites is, this is something that I put together to show more impact to developers. So I have a, first of all, I'm using, there's like several sites out on the web that have vulnerabilities on purpose, one of them by IBM, NT Objectives, and Acunetics. So I think we've all seen the boring alert box, right? Not too interesting. Like developers ask, why is that a problem? So I put together a little alternative, which is the unicorns and rainbow X cross-site scripting. And it just fills your screen, and you don't know why it's doing that. So I have on mouse over events, so every time you mouse over one of the images, it fires a new image, and it just fills the screen soon. That's one option. And by the way, I've got this working on every one of the demo sites. Another option is to show them how, okay, someone can redirect you very seamlessly to another site, like a phishing site. And the big one here is rickrolling. Of course, my advertisement.
You're finally here. Long way from the sandlot.
Okay, there's my rickrolling. And then the last one I have is not quite as dramatic, but it's just creating a fake news story. So you can do all this with JavaScript. So, all right. So quick win number 5. Implement some of these nifty new security-related HTTP response headers. I already mentioned content security policy, and you can learn all about that at 1 o'clock. I think it's over in the Magnolia room. X-frame options is kind of an anti-clickjacking defense, where your site gets framed in another site. The X-frame options header can prevent those kind of attacks. Strict security policy is going to tell browsers that this request, if it's going HTTP, automatically convert it to HTTPS. That's another header that you can use. And so if it's easy in your organization to, if changing code on the functional side is difficult, maybe adding these response headers is going to be easier, and you can get that done without a lot of effort. Another quick win, just make sure your web servers and app server software is up to date. So this goes back to your patching process. How efficient is it? How's it working? I mean, because the bottom line is attackers know the vulnerabilities in old versions of code or products out there. if you run some tests and you see server banners coming back with IIS 6, Apache 2, Tomcat 5, PHP 5.2, any of these response headers that you see, it's probably not, your patching is probably not working, or at least it fell through the cracks on those sites. Quick win number 7. So engage developers and development managers. This has been one of my primary objectives since I started at Sabre. I just want to make sure they're keeping security in mind. We're not a financial company, and we're not a government contractor or anything, so I can't say that it's been in their minds up till now. So it's a slow process, but I'm making progress. I'm also identifying some champions within the development organization. If I see someone, I'm in a meeting or talking to someone, and they express an interest or seem to express interest, ask questions about security, I make a note of them, and my plan is to come back to them later, make them a champion in the organization, the development organization. And really avoid the adversarial relationships. Zane Lackey had a good talk yesterday, I think at like 10 o'clock, about this. Make sure you're not a jerk, basically, when you're talking to the developers, because they'll shut down and they won't ever talk to you again. Do lunch and learns, have guest speakers come in. At Sabre, we have this series that we call Security Tech Talks. They're really targeted for developers, but anybody can come. In fact, Joel Scambray over here came to Sabre and did a talk for us. So those are kind of things that we're just trying to keep everyone engaged. Hacking demonstrations, internal bug bounties. So difficult to do because you don't want to end up with developers writing their own code to buy a minivan. But I think there are some things that can be done. Maybe badges for developers that bring an issue to you that they found, something to encourage like positive reinforcement on that. Okay, I got about 10 minutes here, or 5 minutes, so I'm going to kind of run through this. But so I kind of mentioned early on that in a perfect world, you can roll out a program, formalized program. Everybody's attuned to what's going on, and it's directed from above. So the idea is that with a maturity model, you want to be able to define and measure your security-related activities in your development, and also track that over time to see how it improves. OpenSAM, or just SAM, Software Assurance Maturity Model from OWASP, is a good option. It's kind of a prescriptive approach to introducing security elements into your SDLC. It provides the building blocks for implementing an application security program. It's like the goal is a mature application security posture, and that happens over probably years at any kind of organization that has any kind of size. And so with a maturity model like SAM, you can demonstrate measurable improvements and incremental improvements over time. So let me talk about, in OpenSAM, there's 4 business functions divided into governance, construction, verification, and deployment of software. Under each, there's 3 security practices, and it's nicely color-coded so you can quickly see what's going on here. So to evaluate where you are in terms of AppSec maturity, you get rated or scored on each security practice. And the possible scores are 0 to 3. So if you're doing anything in that particular practice, you're probably going to get a 1. You can also give 1.5, 2.5. But you can measure yourself and see how that changes over time as you implement and roll out new activities. A new activity might be threat modeling early in the life cycle. It might be defining security requirements for every project. These things all go into improving your maturity over time. And so this is where you can see for each practice area, this is an example where if it's plotted over time, you should see that improve and get higher. So that was just a really quick overview of OpenSAM. There's more here at this URL. It's an OWASP project. There's alternatives. That's not the only one. The one that I'm probably most familiar with is the BSAM, or Building Security and Maturity Model, which is very similar to OpenSAM. Many of the same activities can be tracked over time to see how you're doing. But it's more of a survey of dozens of companies and what they're doing with application security. And then that's can also be tracked over time with spider charts. Spider charts allow you to see where you are, just like those last graphs I showed. And you can see yourself and compare yourself against other companies. Microsoft has a really heavyweight maturity model called SDL that obviously it's improved their security over the years. And OWASP, I know, has an older one called CLASP. Focusing on unauthenticated for XSS. The reason I say that is only due to limited time and resources. Because if you have an unauthenticated XSS vulnerability, the thing that is really makes you vulnerable is the possibility of phishing, because you can send someone an email with a link that has a link to the unauthenticated page that has the vulnerability. That can maybe seamlessly redirect them, just like the Rickrolling. It can seamlessly redirect them to like a phishing site that looks exactly the same, and they might get phished successfully that way. If it's an authenticated vulnerability, if that page, that vulnerability is under the authenticated surface area, the user is going to get a login page, and they're going to think they're, the actual login page, because, and so that may not work as well. But that's the main reason: limited time and budget. All right, I don't see anything else. Anyone? Thank you.